Right, okay, well, we'll move into the next session, and I don't need to introduce our next speaker. We've already met Drew, K Oscar 4, sorry, apologies, K Oscar 4, Mike Alpha from AMSAT-NA, but just to change the lecture, it's not on AMSAT-NA. You did get the talk earlier, and Drew is going to give us another interesting talk on another big project, the Fox project from AMSAT-NA, which there have been some very interesting announcements recently. So it'll be Drew. Hopefully, we sort things out, we get things moving.
We might be doing this old school.
No, not acetate.
These are the
Anybody
things,
have an overhead?
These are the things I expected when we changed computers. Yeah.
Yeah.
You do?
Yeah. It's
I'll put it on mine.
okay. If I can.
If you want to carry on talking, I'll...
Sure. There it is.
Yeah, apologies. Anyway, so it's, I won't be here for the meeting at the end. So at the end of the final session, I will have to move off. But I just to kill time, I just want to say a big thank you to everybody. I'll be leaving you, but thanks for joining us. It's been an excellent year again, and I hope I get a chance to see you all again next year or work you on the satellites. It's really interesting what's going on at the moment. So a big thank you, and safe journey to everyone that's travelling back home here.
Like Fox 1, there'll be a slight delay. All right.
Well, they're not commanding a satellite at the moment, thankfully.
Yeah.
But it does let you know that we're in the hands of software.
Looks like the whole thing just is...
He's got... The NSA got us.
No?
Okay, well, I'll just make another announcement. Yeah, I'll give you a talk and a lecture if you like. No, we've during our visit here, we've had the pleasure of the BATC TV group who've doing all the work for the internet, and which will be available for downloading and streaming as well. But there have been lots of inquiries about the group, British Amateur Television Club. And there are a couple of leaflets about, including membership join. If you'd like to join or support them in any way, I'm sure that will be appreciated. But a big thanks to the British Amateur Television Club for all they're doing. The team they have out there have done an excellent job. But they would like, of course, members to join them or a donation or something just to keep on the good work. Thank you.
Anyone have a hammer? It's just not going to there.
No.
Oh. You're getting it? Yeah, that's you. Do you want to start? When it comes up.
Sure. So this talk to you about the Fox satellite program. This is a presentation put together by our VP of Engineering, Jerry Buxton. So we kind of started over with the Fox series of satellites, and the idea was to take advantage of the large and growing interest in CubeSats and the growing number of launch opportunities for CubeSats. We also wanted to develop a family of satellites that carried ham radio transponders that would also be attractive to host science experiments. Cooperation with the universities that could drive us to a launch. And those come through the NASA ELANA program. They're a subsidized launch, but the requirements are educational. It's open to universities and now to nonprofits like AMSAT, and we can work together to get these free rides. So Fox 1A will be AMSAT North America's first CubeSat. The previous smallest satellite we had built was AO51, which was 11 kilograms and about a 10-inch cube. So this is a considerable step downwards in size. Everybody knows that the 1U CubeSat's about 10 centimeters on a side. We've not tried to go that small before, at least AMSAT-NA. The biggest issue is you've got a minimum amount of solar panel area. So you've got to figure out what to do with the power and how to get the maximum power out of that. Am I just cursed?
Yeah, cable was loose on the floor. So fingers crossed that it will. Just do it now. I think it's the VGA cable packing up.
You had another VGA cable down there. Can we set the laptop on the...
Yeah, we can sure try. Yeah, that should be okay. Straight in there.
I'll have to stand over here, otherwise nobody will see the screen. So if we can make this work, that gives us a CubeSat design heritage and puts us back into space. So the mission description's to inspire, engage, and educate the next generation of satellites, satellite operators, and satellite builders. Not to bring up a sore subject, if anybody's read the email lists lately, we did decide to go with an FM repeater on the Fox satellites. This was partially done with the understanding that AMSAT-UK was going to be working on transponders. So there's a certain thing to be said for having balance and more than one type of operation available. So that certainly figured into the calculus on it. You took my notes, man. So the primary payload's the FM repeater. Fox 1A will be carrying a MEMS gyro experiment that was provided by Penn State. It'll also carry a low-energy proton experiment from Vanderbilt University. We're also flying a JPEG camera from Virginia Tech. So we have 3 different universities involved with just the first satellite. We're looking at about an 800 milliwatt RF downlink during full sun periods. Oh. So it's a standard CubeSat looking stack of boards. Can you see it? It's just a little satellite. The top 4 boards are the experiment boards. And in 1A, the very top board is actually a blank board. And we saw a picture of that in the earlier in the earlier presentation where the screen was working. It has a notch cut out of it to fit the lens, and the lens looks out through a hole in one of the solar panels. The next one down is the Virginia Tech. It's the Experiment 3 board, and that has the camera on it. The next one down is the Vanderbilt. Next 2 down are Vanderbilt low-energy proton and the controller board. And then actually the Penn State MEMS gyro experiment is built into the IHU board. They're so small that we just put them on the IHU board. Batteries, battery card, we stuck with NiCads, where we'd like to get is the maximum time on orbit operational out of the batteries that we can. Some of the temperature issues with NiCad or CubeSats and lithium-ion batteries make us a little bit nervous, so we stuck with a known chemistry. It's got 4 A-size NiCads on it. Lots of little things flashing here that you can't see. Standard 70-centimeter antenna, 2-meter antenna, RF cards, separate receiver and transmitter card. Oh. Maybe I could just walk around with this and show everybody up front. This is the transmitter board. You see one side's more or less a solid ground plane, the other side's the components, RF cans. There's a little inscription in there having to do with Tony. Tony was so instrumental in all of this. There's an example of solar panels, 2 cells each. These are the Spectralab high efficiency cells. These are being put together much like the AO51 cells were mounted. Power supply card right underneath the battery card. There's a picture of the engineering model of it. Jerry may shoot me for saying this out loud. We had originally designed or wanted to fly a maximum power point tracking. That one may not make Fox 1A. That may be on the next one, 1C. Battery card, we talked about that. There's a picture without the batteries. If you notice, we're using a much smaller connector than the PC104 connector. That gives us a lot of extra room on the board. This says magnetic attitude control, but it's really just a bar magnet. Same old passive magnetic stabilization. It's mounted over on the side of the structure. And then you have the IHU card and the inputs and outputs from the receiver and the transmitter going into the IHU. So, status, where are we? I got to turn this around. So Fox 1A was accepted into Alana and manifested. We were originally manifested on the NRO Grace mission. That was postponed. That was supposed to go already. It's been postponed to August 2015. Alana said, listen, we know this is a postponement. We've got another Alana mission coming before it called UltraSat. The orbit's about the same. We want you to be ready for that one. They actually haven't told us which one we're going to go on yet. If we go on UltraSat, that'll be Alana 11. That'll be on May 1st, 2015, if there's a vacancy. That orbit is 389 by 700, 58 degrees inclined. If we go on the Alana 12, which is the Grace mission, our original one, it's 470 by 780 at 64 degrees inclined. That's a much better orbit. It's about twice the lifespan. 11 years versus about 6.5 years. This is a really cool slide. You just have to take my word for it. If we're launching on an Atlas booster, and it's, normally you think of your primary satellite, and then underneath it you have the secondaries and the cubes, and then the upper stage. Well, this one's going to be a little different. We're actually riding on the upper stage next to the engine bell. There's a deployer mechanism, a big P-pod. Was developed by it's AMSAT structure. It's by NPSCUL, Naval Postgraduate School. It's got 8 P-pods that go in it, and it goes right on the bottom of the propellant tank, right next to the engine. So the main satellite deploys, the upper stage comes down, brings the altitude down, and then deploys us. Hopefully we're not toasted by that point. Another really cool slide. Apologize. This is on the website. So statuses. In May, we had the engineering unit integration and testing. That actually slipped a little bit into June. Critical design review. In August, we're completing the day in the life of testing, running the satellite through all its paces. That's ongoing right now. Jerry's doing that from home. Outstanding. That's, yeah, that's the... we
Projector to effect up.
So if you go online right now and make a donation, we can back up to the really cool slides. Sorry. Okay.
Almost there.
This is almost like my satellite demonstration yesterday. Okay, there's our launch opportunities. We talked about that. And there's the Atlas. We're going to be right in here. Not up here, right in there. So the aft bulkhead carrier where we're going to ride is down here. Same orbit. I think they're just keeping us away from their really expensive satellite. There's the carrier and the P-pods and where they mount. You see the curvature on the back of the tank here. Engine bell. That's us right there. Primary deployment. They bring the orbit down, and then they deploy us. So we're going through the testing of the flight model and flight spare right now. Vibration testing is next. That'll come up in September. Mission readiness review in September. In October, completion and handoff. It sits on the shelf until January when we deliver it. We're not allowed to do anything to it until it's launched from January. Yeah, it's a little nerve-wracking. Fox 1B. We're originally planned on building 4 Fox satellites, 2 of them with solar cells and panels right up front, and then having 2 in reserve. Because once you spin one board, it's easy to make a copy of it and get it to work. So the second mission, Fox 1B, is known as Rad Effects Sat. And this was a Vanderbilt cooperation. Another Alana launch. It uses the flight spare hardware from Fox 1. It also operates simultaneously with the transponder. I missed that earlier. Our data downlink is going to be encoded in subtones. So the FM transponder will run continuously. The data, low-speed data, will be coming down in the PL tones. So we'll be able to, anybody that's working the satellite that has it hooked up to the decoder at the same time will be automatically making contacts and collecting our telemetry for us. So that we'll also have a high-speed mode, 9600 baud, to be able to get the camera data down, and if we need to get a lot of data down quick, we can switch to that. So with RadFX, we have not yet been manifested. The payload from Vanderbilt's not quite ready yet, so we haven't told them we're ready to be booked on a launch. But basically, we'll reset and start all over again with RadFX, ready in second half of 2015. In the meantime, we have 2 complete extra satellites. So we had those sitting on the shelf. We've been talking to universities, people that are looking to fly experiments. We've made them available. But we had an opportunity that we could not pass up. Fox 1C last weekend was announced that we have arranged for a launch with Spaceflight Inc. On their initial Sherpa launch. Their Sherpa system is this ring system down here. Each one of these is an ISIS quad pack. So there's 3 groups of 7. That's 84 times 3. That's the capability. This is going to have a lot of satellites on it. I can't yet reveal on what launch or what orbit we're going to. I can only say that it's a sun-synchronous orbit, and it's currently manifested for third quarter of 2015. So while we had a lot of the components available and a lot of the satellite already constructed, we do need to raise some money to finish paying for the launch and finish the outfitting of the satellite with solar cells and the testing. So we've started a fundraising campaign. We just kicked it off last week. We need to raise $125,000 to make this happen over the next 12 months. We're currently looking for experiment proposals. We have some that we're talking to, some educational outreach experiments that can go in there. The window is short, so if you're interested and can work with us, contact Jerry on that. We've got donation PayPal buttons, and I understand there's some issues with PayPal in Europe. I will definitely check into that when I get back home. But you can donate via AMSAT.org right on the front page. You can go in via the store and donate, or you can talk to Martha on the phone and set something up. And a recurring donation would be very nice. I see PayPal will let you do that now. One of the things I'm kicking around about doing is a take Fox to launch. So once a month you take us to launch instead of lunch and send us 10 or 15 bucks, whatever you normally spend on a sandwich. So we'd appreciate your support on that. What's next after the Fox satellites? We still have Fox 1D floating around, and we might hear something about it before long. But then we will move on to Fox 2. I don't think that means that we'll never build another Fox 1. We'll just be concentrated on Fox 2, and if an opportunity for another Fox 1 comes up, a 1 Echo or beyond, we can always go back and revisit that. Fox 2 will have flight heritage and track record from the first 4 Fox satellites. Right now the plan is a 3U CubeSat to get a little more power. Software-defined transponder. We flew one of these successfully on ArisSat, even though we had a little missing uplink antenna problem. The transponder still worked. So that speaks well for the transponder. Of course, with the 3U, we'll be able to look at higher power and maybe adding some more bands and modes to it. And attitude, determination, and control is something we're looking at on that. We're currently looking for a partner if anyone's interested on that. So the CubeSat market has grown exponentially, or at least logarithmically. I don't think it's reached its peak yet. I think this is the way things are going to be going, and there's going to be more and more opportunities for the CubeSat-sized payloads. It's not just 1Us and 3Us anymore. The deployers are set up now for 6Us and 12Us. A 12U CubeSat's pretty darn close to a microsat-sized satellite. So we're getting back into familiar territory there. So there's a lot of things that we can look at with CubeSats. Propulsion, although we can't do that on Ilana. On something like a 1C launch where we're footing the bill, we can certainly look at that. Maybe get us to a higher orbit, or satellites in formation. Or another one that has been bandied about a little bit here recently is some sort of deorbit device to let us go to a higher orbit initially, and then still meet debris mitigation requirements. So we're very open to partnerships and possibilities, understanding the contents of my previous presentation. And we're always willing to listen and talk to you about some sort of project and see where we can go. Any questions?
Thanks, Drew. That's really interesting. I want to ask you a question about the Fox 1 sort of construction philosophy in a way. If I've got it right, everything on Fox One, including the solar cells and the EPS, you're actually building essentially and designing in-house?
Everything has been built and designed in-house or with a very close partner.
Okay. I just wondered with the number of CubeSat shops that are around that are supplying components like solar panels and EPSs, did you consider sort of buying some of those components in that way, or is that considered to be cheating?
I would not consider it cheating. I will say that there were some heated discussions at one point over whether we should completely strike out on our own and completely build our own satellite, or if we should use commercial off-the-shelf parts. It is easier to motivate our builders and engineers with a challenge of building something themselves. On the other hand, I very well see the fact that it may be smarter in the long run to use some commercial components, or easier in the long run. So that's an ongoing discussion. It's one that point of view that I personally put forward wasn't followed, but that's okay. I'm not calling the shots on it.
Two questions off the internet. The first from Gerard, doesn't say which country. What will happen with Fox 1C if no payload can be found before the deadline? Is there a backup plan? For example, another fun cube? Second question after this one. Okay,
I'm pretty sure that we'll find an experiment for Fox 1C, even if we just refly, say, the Virginia Tech camera. If something more interesting or better comes along, we're certainly open to it, but the deadline is pretty short.
Gerard's just told me he's from the Netherlands, so it's interactive, this. Second question. Have you any info about the next generation of CubeSat from the State University of New York? Sunny? Does that mean something to you?
They worked, if I'm not mistaken, they worked on a design, a next-gen design for us as a senior project a couple of years ago. We've not heard any updates yet, although the two volunteers that worked on the maximum PowerPoint tracker are from another university in New York. But the next-gen satellite, I've not heard anything recently about that from SUNY. Oh.
Okay, any further in-house questions at the moment? Any?
Thanks, Drew. You mentioned the batteries, and you said you're sticking with NiCads. Almost every other CubeSat for the last 3 or 4 years has been flying lithium. We seem to be the spec says you can charge them down to, is it -5 or -10? I think on the ones that we're using. That is a surprise, and particularly if you've got to leave it in a box down at the Cape for 6 months before you can launch it. That's a surprising decision to me. But what were the real rationales behind the decision?
First of all, I have to put a disclaimer in. I wasn't involved in the decision, so I'm working off of what I've heard on it. I think the overall lifetime cycle was the issue, and the depth of discharge. Beyond that, and temperature figured into it. Beyond that, I couldn't be any more specific. I will say that we're probably going to be forced to something else at some point because the supply for those batteries have already dried up. So.
Okay, any more questions? Another one on the internet.
You may have partially answered this one. Charlie Tango 2 GOY. What will be the solution of the problems of the batteries? We will have some batteries to disconnect? I think he means will we have some batteries to disconnect before they fail?
Well, part of the original design proposal was to include a mode where the satellite would work just off of the solar cells once the batteries had died. That may or may not make it into the first satellite. Another part that has stayed in the design so far is that when the IHU dies, the repeater will continue to work. So if the IHU suffers a fatal flaw somewhere on orbit, we still have a repeater package to use and redundant control.
Okay, I'm going to take one last question from David.
Okay, thank you, Drew. My question really looks at the delay between Fox 1A, B, C. It seems to be very, very short from the timetable you've outlined. And because you've been very ambitious with designing everything in-house, do you think you will have time to correct anything that you learn after flying Fox 1A before the others are committed to launch? It's a very tight schedule.
It is a very tight schedule, and I know that the maximum power point tracker just barely didn't make it on the 1A. So it should be ready for 1C and certainly for 1B. And it's kind of confusing because 1C is going to launch perhaps before any of them if it doesn't slip. So it may be that the maximum power point tracker flies on 1C and is in orbit before the power supply on 1A makes orbit. So there's one last thing I wanted to add, and I don't want to be controversial, but I'm going to be. We're all friends here, and well recognizing that there are differences in operating style and having operated from Europe on several occasions as OZ4 or OZ/KO4MA. FM repeater satellites are much easier to use in the U.S. Our population density is much less. We're more spread out except along the northeast coast. If you guys ever get a chance, go online and go to K8YSE's webpage. If you do a search, he's got a webpage. A lot of recordings from passes in the U.S. You would be amazed at the number of contacts that can be made on an FM pass with just a few less people and a little different operating style. Personally, I put a rare grid square in South Dakota on a couple of years ago, and I made 24 contacts in one pass of UO14. I would dare say you would never hear 24 contacts being made on an FM satellite here. I put that out there as an example of how things are a little bit different and how our viewpoint is a little different and how an FM satellite is a little more attractive to getting users started on our side of the planet. It's really easy to buy a couple of $30 Chinese HTs and build a Kent Britain special cheap Yagi antenna, and you're making satellite contacts for 60 or 70 bucks. So just take that into consideration next time you see the transponder FM repeater running gun battle erupt online somewhere. Things are different.
Okay, well, sincere apologies, especially to Drew and his resilience in the situation as well. Big thank you. We did hire the projector, so it's not ours.